My name is Alex, and this is Watch Repair Tutorials. If you're new to the channel, I'm a retired watchmaker, and I make videos for people who are excited to learn watch repair and service. This is lesson 5 of our series, Getting Started in Watchmaking. Today we're going to go over the process to service an ST36 by starting with the inspection and disassembly. If you're interested in more advanced lessons on watch repair, visit my website at watchrepairtutorials.com. Now let's get started. All right, now before we go ahead and get our readings, let's just talk real quickly about our settings. We have the beat rate setting set at automatic, so it will automatically determine the vibration rate of this movement, which is 21,600. I've got the lift angle set at 46. Now, the lift angle for ETA 6497s is 44, but I've tested these and I come up with a lift angle of 46. So that's what I use. Now, I will check this later and we'll just go over it so you can see how to do that. But 46 is what we're using as the lift angle. For the period of testing, I use 20 when I'm just trying to get a baseline. That's kind of in the middle of the different areas, so you get a little bit more of a consistent rate. Later on, when we get to doing regulation, we'll bump that down to a 4 second period because it's a little bit more responsive. As far as the graft and the graft types, you can select whatever you want. Doesn't really matter. Um, the rate range says plus 999 seconds per day. Anything over 1,000, all you'll get is plus signs all the way across. And that's why you get that, is because it only will measure up to uh, plus or minus 999 seconds. Brightness and auto shut off, you could set those however you want. Doesn't really make a difference. So let's go ahead and start with our dial down position and we'll begin our testing. Now, you want to, at least if you're using the 1900, like I said in previous videos, there's a 30-second settling in period. And basically what that is when you move a movement around, uh, things are getting jostled, the hairsprings moving and flexing and all these type of things. And what you want it to do is you want it to just kind of settle in and start running normally before you actually start looking at your numbers seriously. So what I typically do, if you look across the bottom of the screen, you'll see, plus 10, plus 10, 9, plus 9. Usually what I do, because I want to test for about 60 seconds, is I let 6 of those numbers come up. And when that 6 number comes up, that's when I stop it and I write my numbers down. So there we are, our first position, which is dial down. We have 9 seconds, amplitude of 287, and a beat error of 3. All right, so now we'll check our dial up position. Now, when we look at amplitude, the general rule on new movements and pretty much anything Swiss, there's some exceptions with older Seiko models because Seiko did things a little bit differently back in their day. 270 is kind of the minimum amplitude that you want to see. Now, with that said, when you get into really old vintage watches that have a lot of wear in the parts, sometimes that number is going to be a little bit less. And there's really not a whole lot you can do about it because you're dealing with wear of the parts. And all that wear causes there to be additional friction that wasn't there when the movement was new. All right, so we have our second position. Dial up is 6, 283, and a beat error of 0. Now we go crown up. So 270 in horizontal positions, 270 is kind of the minimum. And that's true even in Seiko watches because they kind of changed the way their philosophy about some of these older movements that were really set up to run at a lower amplitude. Okay, because my understanding, I'm not a Seiko expert, but my understanding is they really didn't care so much about isochronism and for the watch being super accurate. It was all about reliability and longevity. So the idea was the watch ran at a lower amplitude, it was going to be more stable over the long term. Now, how true that is, I don't know. That's just what I've always heard. And now we have our first vertical position. So this is crown up, and we are at 1, 264, and 1 second of beat error. Now we're going to check the crown left position, and you'll notice the crown's right, pointing to the right. This is actually crown left. And like I explained in the other videos, that it's actually reversed when it's on the mic stand like this. So just make sure it's pointed to the right, but it's actually crown left. So again, now when you get to the vertical positions, you're going to see a drop in amplitude because now you're introducing additional friction because the pivots are now they're now running horizontally, and there's more pivot surface on the jewels. All right, and the balance pivots, they're no longer spinning on the end stones, they're spinning on the side of their pivots too. So that increases the friction, which lowers amplitude. And the other factor in that is gravity, because now you have the mainspring being vertical. Now it's sagging a little bit, um, and that sagging also increases the well, it doesn't increase friction, but it adds to the loss of amplitude. Okay, so crown left, we're at 0. Amplitude of 251 and a beat error of 0. And now our fifth position that we're going to test is going to be crown down now. Now, when it comes to watch positions, really, probably the two most important ones, right, is dial up, because that's where, when your arm's sitting on a table, that's where it is a lot of times. Um, you're looking at the watch. So that's a very important position. And the other position that's really important is crown left, because of how people's arms typically sit. Now everybody's different, and depending on What you do if you sit at a desk all day, things might be different, but typically the two most important positions are dial up and crown left. And there we go. So that's a -6, 244, and a beat error of 3. So now that we have our data, we're going to save this on a little piece of paper, and we're going to now get into the movement. All right, now as we get started, I just want to go over briefly what we're looking at here. So we're on the dial side of the movement, and you have your two major systems over here. Everything in the watch movement, I want you to think about as being in a system. Okay. So the first system is our keyless works. And the keyless works is activated by the stem and crown. Right now, it's in the first position. So this is how we wind the watch. You can also tell that it's in the first position by looking at these two notches on the setting lever jumper. This pin is in the first notch. And then when we pull out the stem, there's a little pin that looks like this one right under here, which fits in a groove that's cut into the stem. And when you push the stem in and out, that pin moves the setting lever. So we're in the second position, and this is the time setting position. So what happens is this, when we go from the first position and we pull the second position out, this part called the yoke, which is sitting in a groove in this part underneath, forces, because this part of the setting lever pushes up here on this part of on the yoke, and it's going to engage these teeth in this sliding pinion into this wheel, which turns another wheel, which turns this, which is the minute wheel, which turns this, which is the hour wheel. And this is basically how you set the hands, right? So we have the keyless works, and then you have the motion works. This is the motion of the hands, if you will. And that's how that works. And we're going to break this down a little bit and look at it a little bit closer. Now, this is the hour wheel, and this just sits in loose on top of the cannon pinion here. So we'll go ahead and remove that. And let's look at the other side. Now, when we wind the watch, the gear that's right under here, what it does is it turns this wheel, and this is called the crown wheel. And you can remember that because it's right in line with the crown. The crown wheel turns the ratchet wheel. And this is what winds the mainspring, which is in the barrel underneath here. And then we have the click. And what the click does is the click prevents the ratchet wheel from unwinding because this wheel is under tension. And as the barrel unwinds, it turns the second wheel, turns the third wheel, which is under here, it turns the fourth wheel, which you can see turning here, and in turn that turns the escape wheel, which engages with the pallet fork, which sends the impulse to the balance wheel, and we can see the balance wheel oscillating. So the order of disassembly is not set in stone, but for the most part, we're going to start with the dial side. We're going to remove the keyless works and we're going to remove the motion works first. But before we do that, we first have to take all the power out of the mainspring right here. Now to do that, we want to do this in a very controlled way. And the way we do that is we're just going to slightly turn back on the crown to release this tooth that goes into the ratchet wheel. We're going to hold it back, and then we're just going to very lightly release the pressure of our fingers just enough so the crown slowly turns in between our fingers. And we are allowing the mainspring to unwind inside the barrel. You don't want this to be a very fast motion. You don't want it to happen really fast because it can damage some of the jewels and the stones inside the escapement. And we could just slowly watch the mainspring as it slows down and stops. Now, one of the things that I would point out before we take anything off is oftentimes people will put a movement back together and they wind it up in the balance wheel will oscillate a little bit or sometimes not at all, and they can't figure out why the balance wheel doesn't spin. And one of the ways to check to see, as long as you have power going to it, one of the things that you want to check is to see if the balance wheel is spinning freely or not. Because problems, for example, if you bent one of the pivots, that could cause the balance wheel to run a little bit and then stop, or not run at all. Or it could be a problem with the pallet fork. So what we want to do is we want to kind of work backwards and see what's going on. So the way you do this, or the way you would check it, is you would release all the power just like we did, and then you just take your blower and give it some air, get it going pretty good, and then stop blowing on it and just see how long it runs. Now, if you really want to be technical, you could time it. But what you're looking to see is that it's running freely. And typically it's going to be around, 20 to 30 seconds. I mean, it really depends on the movement, but what you're looking for is you're looking for it to be rotating and oscillating freely. And you want to check to make sure that it doesn't come to an abrupt stop, because if it does, that's an indication that the balance pivot has become slightly bent. And then what you would do is you would turn the movement over and do it again. And you check the other side, because it could be that bottom pivot that's actually the problem. So get it started. And you can see right through this hole the balance moving. So we'll get it started again. And what we're looking for is we really want that to be about the same on both sides. So however long it spins when the dial is down or the dial side's down, you really want to see that same amount of time when the dial side's up. Okay. And if there is a problem, then you would remove the pallet fork and try it again, because the pallet fork could be causing the problem, but it could be related to the balance wheel. So if you remove the pallet fork, put the balance back in, and then did the same test, if it stops, then you know that the problem is somewhere within the balance, in the pivots or the jewels or something like that. But if the balance wheel now rotates properly in both horizontal positions, then you know the problem is with the pallet fork and you really need to get in and inspect it real close. Okay. So it's just something that I wanted to point out real quickly. All right. So let's start our disassembly and we'll go through all these components. Now, in the keyless works, you have a plate that's covering up two intermediate wheels, and this transfers the motion from the sliding pinion to the minute wheel right here. But there's also a spring right here, and you want to be mindful of that spring. So what we're going to do is we're going to get our screwdriver, and we're just going to back that screw out about 3/4 of the way. And then what we want to do is we want to relieve the tension on this arm of the setting lever jumper and remove this from being positioned behind this pin right here. And you can just use a screwdriver and just gently push up on it. So now that tension's been relieved. So now we can go ahead and fully remove this screw. And let's take a look at it. Now you'll notice this screw is undercut. Okay, and remember we were talking about screws, and here is the plate where it's beveled around the hole. So that screw sits flush with the top of this plate, which is the setting lever jumper. Okay? So when you see a screw like this, you know it goes into a plate where the hole has a beveled edge, right? Normally, this is done for clearance reasons, when they don't want something sitting on top of a plate that would interfere with the dial, or they need clearance for another part. Now, I haven't removed this yet, but I'm going to take my screw and I'm going to move it over to the side. And I'm going to get my assembly stick and I'm going to pick up the setting lever jumper, put it in my parts tray. And then I want to relieve the tension from this spring before it jumps out of the way. So the easiest way to do that is to set your stick right on the back side of this spring. We're going to grab it with our tweezers. We're going to grab it with our tweezers, and we're just going to pull it up enough so that it's relieved. And then we can pick it up and put it in our parts tray. Now there's quite a bit of tension in this spring. So this is a flat spring. And believe me when I say this thing will fly a country mile, and it will happen so fast that you won't be able to see it. Now, replacing a spring like this, if you were to lose it, is not that difficult to do. The one for the 6497 will work for this, but you don't want to lose any parts. So you're going to be very careful taking that out. Now we have the yoke. And the yoke slides back and forth and it moves this sliding pinion. Now, when the yoke is in the position 1, these teeth engage with the winding wheel here, and that allows the watch to be wound. When the crown gets pulled out, the yoke moves forward, and these teeth engage with the first intermediate wheel, and that's what allows you to set the time for the watch. So we can go ahead and remove the yoke. We can move the first intermediate wheel and the second intermediate wheel. Now, one thing to be aware of is in a lot of times with these intermediate wheels, there's a right side up and a right side down. A lot of times this will have, it'll have something that might look like a beveled edge, or that bottom edge might have a slight round over to it. These don't have that, but it is something to be aware of. These are both exactly the same. So now we can take that and put that in our parts tray. Now the reason they call this the minute wheel is because when you're setting the time, this minute wheel turns the teeth of the cannon pinion. And of course, the cannon pinion is what the minute wheel is attached to. At the same time, this pinion that's on the minute wheel, it turns the teeth of the hour wheel. And the hour hand is attached to this piece, to this pipe right here. And that's why it's called the hour wheel. So now we can take this off. I would also point out, I don't know how well you can see this, but there's virtually no lubrication in here whatsoever. Now we can remove the cannon pinion. So let's take a look at it real quick. Now, if you look at the cannon pinion, you'll notice that there's a recess right here. Okay. It bumps out a little bit. And there's a little notch here, and there's a little notch on the other side. And these are pressed in. So what they do is they add friction or tension to the extended arbor, which is under here, which we're going to see in just a second. And what that does is that tension allows the minute hand to turn while the watch is running. And when you wind the watch, it allows it to slip enough around that extended arbor so that you can wind the watch. So when you're working with this movement, you want to feel the amount of resistance when you're turning the crown and the stem to see what normal uh what it feels like to normally turn the crown, right? So there should be a little bit of resistance, but it should be very light. If you feel almost none, then that's kind of telling you that your cannon pinion's a little loose. And if it's really hard to turn, then that's telling you that either that cannon pinion is too tight on the arbor or there's something else going on within the motion works. And when you feel it really hard to turn that crown, you want to stop because, these parts are very tiny and these teeth are microscopic almost. And if you put too much tension on those, too much pressure, you'll start bending and breaking things. So we'll get into that a little bit more later on, but let's get this cannon pinion off. So we have our tool, and we're going to go right under this notch. When you squeeze down on it, you can feel it, and then we can just push down, and the cannon pinion pops right off. So looking at the cannon pinion a little bit closer, if we turn this, you can see that notch. It's looks like a little indentation. Then if we turn it to the other side, you'll see another one. Okay. So when you hear people talking about tightening a cannon pinion, what they're talking about is pressing on it right there where that notch is to collapse the cannon pinion a little bit, to push in the wall of that so that it becomes a little bit tighter. Now, is that something you can do with a pair of tweezers? Not really. I mean, you're talking about adjustments within hundredths of a millimeter. So there are tools for that, but nothing we need to worry about at this point. So now let's get on to the watchmaker side of the movement. Now, before we move on to the watchmaker side, or the side with the balance wheel, the first thing we want to do is take out the jewels. Now, if you don't feel comfortable at this point, you don't need to, okay? But you're going to practice putting this movement together and taking it apart and putting it together. But eventually, we're going to need to be able to take these out successfully so that we can clean them and lubricate them. Now, the first thing to know is that jewels are labeled top and bottom. The top jewel is in the balance cock, and the bottom jewel is in the plate. So we're looking at the bottom jewel right now. But it's very important to remember that they're different and you don't want to get them mixed up. Otherwise, the watch won't run correctly. Now, there's all different ways that you can keep track of them. But what I do is I have these little plastic containers that I use for parts and different things like that. And I have one that's marked T for top. And I have another one that's marked B for bottom. And this is how I keep the jewels from getting mixed up. Now, this is probably one of the most widely used shock systems in watches today. And this is the Inca block system. And you can tell by this very distinctive shaped shock spring that it uses. Fortunately, this is one of the most easy to deal with shock systems, which is a good one to learn on. But you still have to be very careful. In this particular one, the spring cannot come out of where it's held. Not true on the other side for the balance. So we'll start with this one. The way it's held in is that this part of the spring is hinged, and then there's two arms that fit into a groove. Now, to release these arms only requires a movement of, I don't know, maybe 1/10 of a millimeter. It's not very much. So you have to use a very light hand. If you push on it too much, you will break it. And to replace this one, you have to remove the entire block from the plate to replace the spring. And parts are not available for these. So if you break it, you're looking at getting another movement. But they're practice movements, so we can expect a certain amount of that when you're first starting out. So don't stress it too much. But let me show you how we do this. The first thing you want to do is just very lightly push on this one. Just enough so the arm comes out from that groove. Once that one's released, the second one comes out very easily. Now, this is a point where you need to stop. The easiest way or the best way to move this spring to open it is to either use your tweezers, or this is just a little probe that I've made out of a sewing needle, and just get your tweezers underneath and move it straight back. If you feel any resistance, stop. But we just want to move it straight back like that. So we got it standing up now. Inside, we have our setting, and we have an end stone that's sitting in the top. So there's two pieces that we're taking out. With our sharp tweezers, we're going to grab the jewel, pick it out, and set it on the plate. Now that we have it out, we'll reposition our tweezers again so we have a better grip, and we can lay it into our parts tray. Now, starting out, what a lot of people will like to do is they will pick that up with a piece of Rodico, and that's okay. If that's the way you need to do it, the biggest thing is you don't want to lose that. Another way you can do it, if your tweezers are not quite sharp enough yet, you can use a tool like this. This is called a jewel picker. And this is a soft rubber, somewhat sticky tip that's on here. And you can use it to pick up the jewel, just like that. Okay? So that's another way you can do it. You can use Rodico as well. Another way to do it is to use a product called gel stick. Now, gel stick is like the jewel picker, but it's smaller. And I usually use these for getting little pieces of dust off a dial or something like that. So this also works very well, and it will also pick up the jewel. Okay. I like these because they're very small and they work really well. But eventually you want to get to the point where you can pick it up with your tweezers. Again, you take it out, and then we put it in our tray. Now, the next thing we need to do is we need to close this, because if we leave it open, it'll definitely get broken. So this one's a little finicky. But now we have it closed, and now we just need to put our first arm in, get it in position, and then we're just gently going to push the second arm, and now it's in position, and now it's not going to get damaged. Now we're going to do the same thing with our top jewel. We're going to start by releasing the first arm, releasing the second arm, and on this one, you want to definitely try to pull it up evenly because this one can come out. And this one can also launch all the way across the room. So we just want to barely get under it. And we're just going to gently, let's see, move it up. We're just gently going to get under it. And we're going to lift it back. And same thing, we're going to pick up our jewel setting. We're going to set it down. We're going to reposition our tweezers so that we got a little bit more meat holding them. And we're just going to put it into our little tray, close up the top, and we'll put those in our parts tray. Now, we need to close it. So we're going to, now if you're using tweezers, you don't have a probe like that. You just want to get your tweezers and gently lay it down. Nice and easy. We get our first arm under and our second arm. Now it's protected and we don't have to worry about it getting damaged. Now with our jewel out, we can remove the screw for the balance wheel. We're going to get this out of the movement first. There's our screw. Now, before we lift this out, underneath the balance cock, about here and here, there are 2 pins called steady pins, which run into the plate. And those help and are actually what lines up everything for the balance cock as it sits here. Screw holds it into place, but the steady pins are what holds it in the correct position. Now you'll notice right on the plate, right here, there's a little notch that's in the plate. And that's where sometimes you need to stick a screwdriver, but to loosen up these steady pins. But we're going to try it with our tweezers. So you can see it's actually not very tight. And then what we want to do, because our balance wheel is under the second wheel, we're going to lift this up a little bit and we're going to tilt our movement until it breaks free. And now we have our balance out of the movement. Now, you could just sit this down at this point, nice and gentle, and then grab the wheel and the balance cock and turn it over. And then you want to pick up the balance wheel so that the pivot goes in its hole. So there we are. And now we can move this to our parts tray. The next part that needs to come out, and we do need to be careful with this one as well, is our pallet fork. So we have 2 screws in the bridge. I got a nice tight fit on my screws. This is the same driver that I'm using for the other plate screws. We take out our first screw and our second screw. Now here's where you want to use a little caution as well. So here's our steady pins for the pallet fork bridge. These are the ones that were, these are the steady pin holes for the balance, okay? But we want to lift this up. We don't want to pry it so that the pallet fork bends. So we don't want to lift it so that we're putting any kind of lateral pressure on that pallet pivot because it's pretty small. So using a screwdriver or a probe, we're just going to get under the plate and we're going to loosen it up. Now this is a lot looser than what you normally see, I've got to admit. But that's the pallet bridge. So we can put that in our parts bin. And then when we lift out the pallet fork, we want it to just come straight up. Now you'll notice that a little bit of power got released. That's nothing to worry about. A lot of times, especially when it's a brand new movement, there could be just a tiny bit of wind still in the mainspring, but that's certainly not going to damage anything. Now you could be using a movement that has 2 plates. This is a 3-plate movement. So we'll start with removing the cock for the escape wheel. I gotta say, these T-shaped screwdrivers really feel good in the screw slots. One of the other things you might have noticed, obviously, is that we have blued screws. Just be aware that these are not real blued screws. These are done, it's a cold process. It's basically dipped in a liquid to make them look like they're blued, as opposed to blued screws that are done with heat. Same thing on this cock. There's a little notch right here. We're just going to get under it and lift it straight up. And that's our escape wheel cock. Cock is typically used when there's 1 screw holding it. When there's 2 or more, it's considered a bridge. But again, we're going to lift it straight up and out. And that's going to go in our part tray. Next, we're going to remove our 3 screws that hold on the train bridge. Before I do that, I just want to point out the really sloppy oiling on this third wheel pivot, on this third wheel jewel. You can see there's oil all around the edges. Now, these are done by machine, and I'm not sure exactly what happened, but there's actually debris. I don't know if you can see that, but there's debris all around this, embedded into that oil. So we'll take care of that later. I'm just going to grab a little piece of Rodico to dip my tips of my tweezers in to clean that oil off. So now we can go ahead and remove our 3 bridge screws for our train. You'll often hear me refer to this as the powertrain, the train of wheels. It's all the same. So we have all 3 screws loosened. We can take these out. I didn't quite get that one loosened up enough. And then we're just going to gently lift the bridge up. Sometimes on these large bridges, you have to give it a little bit of finesse to pull it out. But there's our bridge. And now we can see we have our 4th wheel. We can take that out. This is what our seconds hand runs on. We can now take out the 3rd wheel. And what we have left now is our barrel bridge. Now I'm going to start with removing the click. Now the click is this part, but there is a spring underneath here, but it is under no tension. So I'm just going to remove the screw. And we can remove our click. Now this is a round spring. There's a straight part that comes up that fits into the click, and then there's another 90-degree piece that goes down inside that hole. So we want to be very careful picking it out. Put that in our parts tray. Now we'll remove the ratchet wheel. Now the ratchet wheel, because we removed the click, it has nothing to stop it from turning, right? So if that click wasn't there, if you wound it up, it would just keep spinning like this, right? So I'm just going to use my assembly stick. I'm going to put it here And I'm just gently going to turn it until it becomes loose. There's our screw for the ratchet wheel. Our ratchet wheel, you'll notice, has a square hole that fits over the square part. This is the top of the barrel arbor. And now we get into the crown wheel. The crown wheels typically have a reverse thread screw. On a typical screw, people say, you've heard the term lefty loosey, righty tighty. Well, on this screw, it's the opposite. Many times, reverse thread screws will actually have lines cut into them that are perpendicular to the screw slot, but this one doesn't. So we almost always have to assume that this is a reverse thread. Now, in a lot of older pocket watches, not a lot, but in some of them, like certain Hamiltons, for example, the ratchet wheel here, or I'm sorry, the crown wheel right here will have a hole in it, and it has another part under it that keeps it from unwinding, and which is the reason that they use a reverse thread screw. Because of the winding motion, the screw is opposite of that, and that's what keeps this from unwinding. Okay, so that's why the reverse thread. So we got our screw in, we get our driver in, we got a good fit, and we turn it to the right. Now, here's another thing that you need to be aware of before you remove this, is that there's a ring. It's a separate piece that is inside of the ratchet wheel. So a lot of times when you lift it out, it'll come out as one piece, and if you're not aware it's there, it'll get lost. So here's the ring. So we put that in our parts tray. The crown wheel can go in our parts tray. And now we can remove the bridge. We have 2 screws. There's 1 and 2. Screw number 1. Screw number 2. There's our notch. We lift the bridge straight up. And now we can remove our second wheel, our barrel, now this is the setting lever screw. This is what you turn when you want to remove the stem. It loosens up that setting lever on the underside and allows you to pull the stem out. So there's our stem. We have our winding wheel. sliding pinion with teeth on both sides. And now we can finish removing our setting lever screw. And what happens is our setting lever will fall out onto our table. And there's our setting lever screw. And now the movement's apart. This video series is made possible by the generous contributions of my patrons. I don't make videos for views. My goal is to pull back the curtain of watchmaking and make it more accessible to the masses. My patrons are able to not only watch these videos commercial free, but I upload exclusive content only available on Patreon. So if you like this kind of content, consider supporting the channel. I'll leave a link in the description. In our next video, we're going to go over how to wash the parts, some of the inspections, and get ready to reassemble the movement. And because there's so much more to learn, I'll see you in the next video.